Second to last, I want to talk about polynomials. So a polynomial is any expression with just some x's, some constants, and some integer powers. That's really all there is. So maybe the poster child for polynomials is the quadratic. We spend a whole lot of time working with those. So I can take x squared minus 5x plus 2. There is a quadratic polynomial. Let me just make up another polynomial here. This time I want minus e, that's the constant e, x to the 7th. I'm going to add to this x to the 4th. I'm going to take away 1 on 100 x cubed. I'm going to subtract 2x squared, and then I'm going to add 3. That's another polynomial. So we like to classify polynomials by their degree, which is the highest power of x that appears in them. When I write polynomials out like this, it's nice to pick out the different terms. So starting with the lowest power of x, the constant, which is x to the power 0. I'll write this a little bit backwards. My constant term is also called the linear term, right? That's my x to the 0. I'll even put in an x to the 0 to show that it doesn't change anything. So excuse me, my constant term. The linear term, getting my wires crossed, the linear term is the x to the power 1, though you can see already that sometimes we just omit that exponent. The quadratic term is the x squared. The cubic term is the x cubed. 4 gets the name quartic. 5 gets the name quintic. 6 gets the name septic. Yes, it does. Isn't that kind of funny? And after that, we kind of run out of names. Like there's a couple more Latinate words in there you can use, but that's not actually important for working with these on a day-to-day basis. Whatever the highest term is in the formula, we're going to give that same name to the polynomial. So this would be a quadratic polynomial. This is a degree 6, so this is a septic polynomial. I mentioned cubic polynomials the other day. Here is a cubic, and so on. One of the properties of polynomials is that they might have roots. They might not. I can move that up. Now that, that's a little too far. Now this red quadratic polynomial does not have any roots. I can move that down. Now it has 2 roots. Somewhere in between, it might be a quadratic with only a single root. The most number of roots that a function like this can have is it can be at most the highest degree up top in the powers of x. So a quadratic can have at most 2 roots. Let's get that cubic back in here. This cubic has a single root, and cubics in general can have at most 3. So let's put in a minus 10x squared. Oh, I had it just a bit. There it is. So now here's a cubic with exactly 3 roots. So polynomials are fairly nice functions to work with. And they also encompass the easiest functions of them all, linear functions, the lines. So this is good old y equals mx plus b stuff. For this example, I'm actually going to put some sliders down. So written out this way, the m is controlling my slope. Positive slopes go in this diagonal direction. Negative slopes go in the opposite diagonal direction. 0 slope gives us a horizontal line, and so on. And my B slider is the y-intercept. This is controlling where the function hits the y-axis. Or you can also think of it as when I plug in a 0, what's the number that I get? So I can change each of these knobs independently from one another to get different kinds of functions. Okay, I think that is enough on polynomials. So I will catch you for my final video this evening where we talk about radicals.